Chapter 12L, question 3. In this question, we're looking at more of a properties question of the unit circle. So we've got given that cos x equals 3 over 5 and the domain is 3 pi over 2 is less than x is less than 2 pi. Find sine x and tan x. So notice in this question, we've been given an exact value. So 3 over 5, or a ratio of 3 over 5 for this value of x. And we're told that x lies between 3 pi on 2 and 2 pi. And we want to find this value and this value. Now, the way in which we can approach this question is we're going to use the unit circle to help us understand the domain in which we're working in. So instantly, I'm going to draw up my unit circle here. Draw a nice circle, nice perfect circle, like so. And then I'm going to look at the angles. So I know it's 0 radians here. It's pi over 2 radians, or pi over 2 radians up here. This one is pi radians. Over here is 3 pi on 2 radians. And over here, this is 2 pi radians, so the full rotation. And what this question tells me is that we're between 3 pi on 2 and 2 pi. So 3 pi on 2 is down here and 2 pi is over here. So what this is suggestive of is that we're only in quadrant 4 of the unit circle. Now, looking at the exact value we're given, we're told that cosine of x is equal to the ratio of 3 over 5. So firstly, notice that this is positive, which is consistent of what we'd expect for being in quadrant 4. So remember, all stations to central. So cosine is positive in quadrant 1 and quadrant 4. So the question at hand tells us we're working in quadrant 4 and it's given us a positive ratio within quadrant 4. So thus far, everything seems to be making sense right now. So let's go back and we'll have a look at the ratio, and remember that cosine of theta is the same as writing the adjacent over the hypotenuse. And that's relative to having a triangle as such. Theta is here, our adjacent is down here, and our hypotenuse is over here. So simply looking at this guy over here, if I want, I can get this purple triangle, and we'll go 3 over 5. So this is the adjacent, this is the hypotenuse. So I can say that the adjacent here is going to be the equivalent of 3, and the hypotenuse is the equivalent of 5. So then it becomes a question of, what is this value here? So looking over here, sine x equals the opposite over the hypotenuse, and then tangent of x is equal to the opposite over the adjacent. So notice that if we calculate the value of L, we're going to know the opposite. And thus, using this reference triangle here, we could figure out the ratios of sine x and tangent x. Now, I'm not going to do this in this video, because if I do, then I'm simply giving the question away. But what I want you to do is, using the steps that I've demonstrated here, I want you to follow along, write it down, then I want you to solve the opposite. And then when you get the ratio, whatever it is, I want you to think about sine x, and I'll do that in purple. Let me write that in purple. I want you to think about sine x is the opposite of the hypotenuse, but I want you to think about, is it positive or is it negative? Think about the quadrant. we're in. So think about the quadrant we're in and then decide whether you think the solution or this ratio should be positive or whether it should be negative, and reference it in that we're working in this guy here. And then do the same for tangent. Think about whether you think this ratio should be positive or negative.